Hello. In this video, we will talk about resource dependencies. Terraform supports two types of dependencies. Those are implicit dependency and explicit dependency. We will discuss and do hands-on on both of these dependencies. Also, we will cover startup script in this video and do hands-on to show how startup script is implemented using Terraform. Dependency identification is very crucial for setting up an environment because if required dependencies are not identified and taken care, desired resources either cannot be created or even if they are created, they will not work as expected. That's why Terraform has implemented this very nicely. So let's talk about dependencies, and first let's see what is implicit dependency. Implicit dependency is the dependency which Terraform automatically identify between the resources and sequence the resource creation based on this identified dependencies. For example, when configuration of a compute instance is defined and this compute instance must have a static IP, the static IP must be created and supplied to the compute instance configuration. That way, when Terraform executes this configuration, it will automatically identify this dependency and create static IP before it starts creating compute instance. Another type of dependency is called explicit dependency. This dependency is defined by user to control sequence of resource creation as per the user requirement, so that resources are created in the sequence the user has defined. Explicit dependency can be defined using argument called depends on, and supply the list of resources needs to be created before this resource is created. If creation of any those resources are failed, this resource also will not be created. For example, if a storage bucket needs to be created before a specific compute instance resource, in this case, within the block of compute instance, we can define this explicit dependency within the square brackets. And when this configuration is executed, storage bucket will be created before the compute instance. We will experiment both of these dependencies in the hands-on session. Now let's talk about the startup script. Startup script are those scripts which are executed as part of compute instance creation, so that compute instance can be set up as per predefined requirement. One example of this kind of script is install required software in the VM and set up the application so that as soon as VM creation is done, it is ready for use by users. In this example, we will set up nginx web server as a startup script in the compute instance. Also, open up the firewall to allow HTTP traffic to this VM. I am taking these simple examples which can give you a kickstart for using these features, as well as you can get ideas to implement more complex scenarios. So let's do the hands-on now, and first we will experiment dependencies and then startup script. We are using the Visual Studio Code for our coding. So you can see we have already created one configuration to create the compute instance image from our previous video. So we will utilize this code only, but we will create a different directory to experiment dependencies and startup scripts. So let's create a directory here. Inside P2 we will create Terraform configuration file, and we will copy everything from the previous project to this one. I close that, the previous one. So as I go through this code, we have a provider which is Google. As you know, we are experimenting everything on the GCP, and this provider need three arguments: credentials, project, and the region, which I have already provided here. So credentials, if you see my previous video, I have created a service account and downloaded the JSON file from there. And this is the project name, Terraform demo. and some random number, and I am utilizing region as a US central one. So this is my provider resource. We are creating compute instance. Inside the instance I have provided the name of the instance, what's the type of the machine, and creating this instance into US central 1A zone. Boot disk I am creating Debian 9, and in the network interface I am using the default network because I have not provided anything in the access config. So it is creating right now the dynamic IP address. So to create implicit dependency, we will create a static IP, and we will provide a static IP reference here. So to do that, we will go into the Terraform documentation. We will utilize the Google compute address resource. If you go into this Google documentation on Terraform, inside the compute engine, let's minimize the data source. Under the resources section, you have the Google compute address documentation. There are a couple of examples given here. One is the basic address, one with the subnet, another with GCE endpoint, and this is the instance with IP. We can utilize this particular example, and from here, before we explain that, let's see what all the arguments are provided here. Only one argument which is required is the name. Rest all the arguments are optional, and there are attribute references and the timeout and the import. So let's look into this example. Here is the Google compute address resource. So we will copy this one and let's go into our code and paste it here. Let's rename this one as a, so I have changed this name as a static IP. If you look into this example, this compute instance, inside the network interface and access config, it is utilizing this static IP to assign to this compute instance. So let's copy this portion and paste it here. So Google compute address is the resource name which we are going to create, and the static is the name of this resource inside this Terraform config, which I have changed. So I will change this here as well. And the address is the IP address which it will return, and that will be assigned to net IP. That's it, the configuration. So in this, what is happening when this configuration is executed by Terraform, it will automatically figure out that before creating this compute instance is dependent on the Google compute address, and this is defined in this particular resource block. So this resource block will be executed first, and static IP will be created, and that particular static IP will be utilized with this compute instance when it will start getting created. So first it will create the compute address, then it will create the compute instance. So let's try this one. So first thing, we will run Terraform init. Terraform init is successful. We'll run the Terraform plan. So you see here, it is going to add two resources. And if you go back, if you go on the top, it's going to create the static IP, and it is going to create the compute instance. But the way it is displaying here, that it is displaying the compute address and then displaying the compute instance, it does not mean that it will be created first and this will be created after that. This dependency is identified internally, so it does not show the dependency here. Let's run the Terraform apply. Before we run Terraform apply, let's go into GCP and check the compute engine. There is no instances here. As well, we will go to external IP addresses. There is no external IP address as well. So let's run the Terraform apply. If you see here, it is creating static IP. It is not yet started creating the compute instance. So now if you see here, static IP creation is completed. After this is completed, then only it has started creating the compute instance. Both the resources has been created. So main thing is to see here the sequence, how these resources has been created. So here we have this VM created, and it has this external IP assigned to it. And if we look into the external IP again, you will find the same IP there as well, 89.99. Here we go. And that's the name of our external IP address which we have defined in our configuration file. So that's how implicit dependencies are identified by Terraform. That's how it sequences the creation of the resources. Now let's experiment the explicit dependency. For that, let's destroy this resource. While this resource is getting destroyed, let's update our configuration. So this is the implicit dependency, and let's define explicit dependency also here. So to define the explicit dependency, I'm going to create a storage bucket. So let's go to the documentation again. So if you go to the Terraform documentation, you will find cloud storage. Inside that, you have the resources. Under the resources, you have a storage bucket. So a couple of examples are given here how to create the storage bucket. But if you see the arguments, only one argument which is mandatory. Rest of the arguments are optional. So if you don't provide the optional arguments, Terraform will pick up the default values. And these are the attributes here. So I'm not going to provide any other argument except the name. So let's pick up this one. Paste it here. I don't need to change anything inside this, so let it be the name whatever it is. Now to create the explicit dependency, as I explained in the theory session, we need to define a parameter here called depends on. And we have to supply the name of the resources. So I'm going to pick up this one, its name. I'll change this name. So I'll utilize this. That's it. So before it starts creating the compute instance, it will definitely go ahead and create the bucket first, and then only it will start creating the compute instance. So in this code, we have both the dependencies defined. This is implicit dependency and this is explicit dependency. So let's try this one. Our resources also got deleted. Let's go to GCP. Here we don't have our VM instance. And we go to the storage. We don't have any bucket. And if we go to the external IP address, we don't have any external IP address. So let's go ahead and run Terraform plan. Now if you see here, 3 resources are going to be created. This is the bucket which we have defined. This is the compute instance. And this is the IP address. So let's apply this. I'll say yes. And if you see here, you can see 2 things are getting created. One is the static IP, another is the bucket. And both are created in parallel. There is an error. Let's see what's the issue here. Okay. So the name has to be global name. So looks like the name which we have given into the configuration file is not unique. So let's change the name. To change the name, let's use our project name. Hopefully this should be a unique name. Let's try Terraform apply again. This time it's creating only 2 resources because IP address creation has been successful. So it is going to create only the bucket and the instance. I will say yes to it. It will first create the bucket and only it will create the compute instance. So here you see the bucket creation is completed. After it is completed, the instance has been started creating, and if you see, both the resources has been created. But thing is that you have to see here the dependency has been taken care by this. One more thing I want to just explain. In the previous run, when you saw that storage bucket was not created and it threw the exception, because of that compute instance also did not get created, because compute instance can be created only when it's all the dependencies has been successfully created. Now let's go to the GCP and look into that. Here the VM has been created with the static IP. Go to the storage bucket, and here our storage bucket has been created with all the default parameter, like location is multi-regional and location is US, and then storage class is standard, and all those are the default values. Go to the network and see the external IP that also got created. So that's how we have seen that how implicit dependencies are taken by Terraform, as well as explicit dependency is taken care by Terraform, and how we define into our configuration file. Let's talk about the startup script. I am doing this recording next day, so I have destroyed all the resources which we have created for the previous exercises. So to define the startup script, we have to use a metadata which is called metadata startup script. So let's look into the documentation. In the Terraform Google Compute Instance documentation, you can see this metadata startup script. So we will use this metadata in our code. Here either you can supply a file, as we are supplying a file for the credential, or you can just write down the script here. So I'm going to write down the script in this code itself. Because we are using Debian 9, that's why we are using the apt-get, and apt-get update will download the package list from the apt repository. Next, so two commands are separated by semicolon. So it is basically it will execute this command, and after it is completed, then only it will start executing the next command. Here I am using the assume -yes, so that it will not prompt us for anything. So it will consider everything as yes. After installation of nginx, we will start the nginx server. So that is the command. So metadata startup script will be executed after this instance has been created, and it will install the nginx and start the server. But to reach to this particular server, we need to open up the firewall as well. To open up the firewall, we will add the firewall script here. Let's go to the documentation again. Google Compute Firewall is the resource name which we have to use, and if you see here, there is a sample example. In the argument list, only two arguments are mandatory, which is the name and the network. Rest everything, it will pick up the default value if you don't supply these arguments. And these are the attribute references and timeout and import. So let's copy this code from here, paste it here. I'll just change the name. Because I am using HTTP port and I need only HTTP 80 and 8080 port on the TCP. ICMP is fine because it is required for the pinging the server. I don't need source tag. I need one more parameter to specify the IP ranges, which is called source ranges. So I will copy this parameter from here. So I'm not restricting any IP, just giving the 0.0.0.0/0, which will allow any external IPs to reach to this particular server. I don't need source tag, so I can just delete this one and save this. Okay, here is the network name. I will, instead of that, I will just give default. Looks fine to me. Let's try this. So it's going to create 4 resources. So one is our bucket, the instance, the firewall, which we have just now defined, and the static IP. Let's apply this. I'll say yes to it. So as you can see that static IP, firewall, and the bucket, all 3 have been started in parallel. After the implicit and explicit dependencies are created, the compute instance is started creating. Now all 4 resources has been created. So let's go into the GCP and check that. So here is a VM, and let's go and check the firewall. So this is the firewall which is created. If we go inside, and this firewall has been applied to this particular VM. Go back to the compute, and if I hit to this IP, it should open the nginx homepage. Let's try that. It's saying it can't be reached. Let's check that. So nginx server is up and running. So try it again. Here we go. So sometimes it takes a bit of time to install the software and get it ready. So you can give some time to the VM instance to get it ready. So now you can see that it is launching this nginx homepage. So that's how we define the startup script in the configuration, and if it is required, we have to define the firewall or any other required dependencies for the application, so that when application is launched, it works fine. That's it, guys. So this is what I wanted to cover in this video. Thank you.